Hi, I am Samantha Friedler, and the experiment that I conducted is titled The Effects of Copper Sulfate Pentahydrate on Pole Bean Seed Germination. Heavy metals are a group of metallic elements with high densities, atomic weights, and numbers. They are found throughout Earth's crust and are naturally present in soil. Examples of these elements include mercury, copper, and arsenic. Despite their natural occurrence, geologic and anthropogenic effects drastically increase the concentrations in which they are present in soil. Activities that are found to increase heavy metal concentrations include mining, burning fossil fuels, the use of fertilizers and pesticides, and the smelting of metals. In high quantities, these metals become incredibly toxic and cause a wide array of problems to their surrounding area. Prior to this study, I researched how different heavy metals affected a wide array of plants. I was made aware that heavy metals are often absorbed through plant exudates and inhibit the production of cytoplasmic enzymes. Additionally, I learned that the processes of bioremediation, phytoextraction, phytostabilization, phytovolatilization, and microbes can be used to deplete areas contaminated with heavy metals. This research specifically tracks the short term effects of the chemical copper sulfate on pole bean seed germination in order to gain an overall idea of its impact on plant health. Pole bean seeds were used due to their relatively easy nature to grow and germinate. Copper sulfate pentahydrate was used in light of this being an at home experiment and its solubility in water. This is a list of the materials that were used to conduct the experiment. The lamp, bowls, saran wrap, Sharpie, and paper towels were used for the setup of the experiment, and the micropipette, copper sulfate, funnel, measuring spoons, test tubes, and pole bean seeds were used for the reaction. On the right, you can see an image of my setup of the experiment, and these are pole bean seeds. That's also a micropipette. This is a list of the concentrations of the solutions. The amount of water was kept constant in each test tube, and the amount of copper sulfate was increased by 2.1 grams. These measurements were calculated using information from data collected in the article, The Effects of Copper on the Growth, Photosynthesis, and Nutrient Concentrations of Phaseolus Plants. To conduct this experiment, I labeled 8 test tubes with a specific quantity of copper sulfate and a number to indicate what bowl they corresponded to. I then set the test tubes aside. Next, I dampened a paper towel and laid it inside each of the bowls. I then placed 4 seeds on top of the paper towel and set the bowl aside. After this, I measured out the quantity of copper sulfate I needed using the measuring spoons and used a funnel to put it in the correct test tube. I then measured out the water and used the funnel to add it to the test tube. Once the solute and solvent were in, I shook the test tube until a clear solution formed. I then used the micropipette to measure out the quantity of the solution I needed and dropped it on top of each of the seeds' coat. Lastly, I threw out the tip and began the process again for the other concentrations of the solutions. After all was done, I waited 9 days for the seeds to germinate before recording my results. After germinating for 9 days, the results proved that as the concentration of copper sulfate increased, seed development was increasingly damaged and some didn't even sprout. In bowls 5 and 6, black speckles began to appear on the coat, and there was very minimal plant growth in comparison to the control group, which was bowl 1. All in all, this research greatly backs the theory that copper sulfate negatively impacts plant health and especially affects seed germination. These are images of the seeds in each bowl after 9 days of germinating. As you can see, bowl 1, which was the control group, grew significantly more than the following bowls. This is a graph showing the correlation between the concentration of copper sulfate and the number of seeds that germinated. This is an indirect relationship. This chart shows the observations that were recorded after the germination period. Bowl 1 had large plant growth and green leaves, and as we moved to bowl 6, only 2 out of the 4 seeds grew, and there was very minimal plant growth. Future research involving copper sulfate should delve into the ways in which the chemical can affect the human body. It is already known that it quickly absorbs into the bloodstream and causes rapid eye irritation and organ damage, and even the potential risk of developing kidney cancer. Using this information, future research should further explain its mechanism of action in the body and its overall long-term effects on health. Thank you for listening.